In this video, we're going to do just a real quick review of natural exponents and natural logarithmic functions. We mostly just deal with the natural ones. We don't deal with just like log base 10. A natural logarithm is a log base e, basically because they're inverse functions of one another. Inverse functions we'll go over a lot more in detail later, but basically their domains and their ranges are switched. And they are reflected across the line y equals x. So if you notice the graph here, if I were to graph the line y equals x, I should be able to see that this line here is a mirror image across this line. And again, that's because their x's and y's are switched. So in the inverse, the y values are the x's, and in the original, the x values are the inverse's y values. So our inverse relationships here, if we have the natural log of the natural exponent, because they're inverses, they cancel one another. So these can cancel, and we're always left with whatever that exponent is. The same is true if we're taking the natural exponent of the natural logarithm. Again, they are inverse functions, and all we're left with is what was inside the natural logarithm. These don't apply if, let's say, there's more stuff in here. So if this was like e to the 2 ln x, the e and the natural log cannot cancel because of this 2. We can rewrite it, but they can't cancel as it's written. So just again to review, exponents and natural exponents are exactly the same as regular rules of exponents. When you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. And then just kind of keep in mind these graphs. The only thing that you really have to know with the natural logarithm is that basically, like, it's never going to come here and cross 0. So it has to be positive. I can't take the ln of -1. That doesn't make sense because there's no graph over here. And again, conversely, I can't have e equal to -1. Like, this is never true because the y values in e never come down below the x-axis. So the only thing that you need to know about natural log is this value right here. The natural log of 1 is 0. So you do have to know that one. All the rest, you just leave because they're decimal. So ln of 2 is just ln of 2. Remember, since these are inverse functions, the ln of x equals y, that means in the inverse, these two are switched. So if I look in the natural exponent function, I just flip these two. So I know that e to the 0 equals 1, which has to be true because any number to the power of 0 equals 1. So that guy has to be there. So properties, if you see this graph, right now we're talking about natural logarithm, which is this one here. This guy is e to the x, but it's always increasing forever and ever till it goes to infinity. It's always concave down. We'll talk about concavity a lot later. And those are probably the main important things. It is continuous, meaning there's no breaks, no gaps, no holes. Okay, so here are some properties. Again, these all should be reviewed. This is the only ln you actually have to know. When you have multiplication inside a natural log, it can turn into addition. When you have an exponent here, this exponent can come in the front, so it turns into n times natural log of a. And then when you use division, you subtract. So we're going to use the properties of logarithms to do 2 examples. Real quick, let's just maybe take a step back, and I do want to explain, remember, that ln and e are inverses of one another. So that's one of the reasons like division turns into subtraction. That's what we do with exponents as well. Multiplication turns into addition. Again, we do that with exponents. So if we were to then expand, we're just going to like split it apart. Here, because we have 3 bases being multiplied, we're going to split those up into addition. So this becomes ln of x plus ln of y squared plus ln of z. And for the purposes of this class, this would be far enough. This is very helpful. If we wanted to go one step further, we could actually take this exponent here and move it in front. So this would be fully expanded This would be easiest for what we're going to use in this class, but that's not that much easier than the red. The red is 100 times easier than what we started with. So it's just important that you kind of know how to work with them. And number 2, we're going to do something very similar, only here we have division. So we're going to take natural log of e to the 2x plus 1 minus natural log of y. And then again, because ln and e are inverses of one another, they do cancel. And that's going to make our lives a lot easier when we start doing the actual calculus problems. So we're left with the exponent, and then this guy's just going to drop down. And that would be as simplified and expanded as we can get.